All right, it's Wednesday evening. Made a lot of progress the last 2 days, 3 days maybe, on the GPS Disciplined Oscillator. I got the frequency synthesizer section all done, and haven't gotten the auto tuning in there yet. But let me just go over what we have. The first thing I did is I changed the GUI, or changed the screen. So I have the date and the time. I still have the number of satellites. This is the elapsed time. And I have the current value of the phase in hex, and then I have the character position of where the rising edge is. So 3, that's 3, then goes to 2, that's position 2. That's just for debug purposes. Then I have the graphical display so you can see how it's moving. So since it's walking left, you know that you're running fast. This value is the current count of the number of clock edges, and so these should, in perfect world, differ by 128. So 35, 163, that's 128 apart. This is the current error, so it's 0, and then I have the current running total of how long that error has been occurring, and then I have the capture of the latest. I have the DAC setting, the manual auto indication, and then here I have the control for the frequency synthesizer, which I will talk about now. So here in the control panel, this is the, I got rid of the LEDs that show the phase. So here I have the auto manual switch, and so if I switch that, it turns to A, but there is no auto mode. And then, this is the up and down 100 DAC count, up and down 10, up and down 1 DAC count, which I've been using for a long time. And what I added are these controls over here, which is for the frequency synthesizer. So right now I'm putting out a signal that is 10.7 megahertz, and there you see it on the display. And that 3 there, that's just the inaccuracy on the time base inside the scope. I have a control here which shuts off the output, and so you're not junking up things. There is these 2 buttons change what digit you're changing. So you see the cursor there. If I move it up, I'm changing, the tens position, ones, the 100,000, 10,000, and so forth. And then these 2 buttons change that digit up or down. And so if I wanted to, go faster, I would just press up. So now I'm at 10.8 megahertz. Now these switches are sort of a mode switch. So the S here means that I'm in set mode as opposed to enter mode. And of course, those are kind of ambiguous terms. What's the difference between setting and entering? Setting means that it will, as I change the value here, you can see the value or the width of the trace change there. If I flip this switch, I'm in enter mode. And so when I'm in enter mode, I can change the value. So I'm going to change it to 10.6, and it hasn't changed on the output yet. And so when I press this button, the set button, there you see it, it's changed. And the oscillator can go from basically 90 megahertz. Initially, it went down to 500 kilohertz, and no farther. And that's because the way the frequency generator works, there's a maximum divide of 2000. And so if you're running at 900 megahertz, the slowest you can go is 450. And I wasn't going to implement it, but there's an additional divider in the output stage. So you can divide by 1, 2, 4, 8, 16, 32, 64, or 128. So you can actually get down to 8 kilohertz, which I actually then today just now finished. And so you can run this thing as again down to 8 kilohertz. So if I put it at let's change some of these values. If I change it, so there I'm at 635, 630 kilohertz. I can then we can then change this so it's 30 kilohertz, and there's 30 kilohertz, and I can then start incrementing that even lower. And in the code, as you go slower and slower and slower, or faster and faster, I can do 84, and so now I'm at 84, and of course you see the inaccuracy. I'm off by 5 hertz. If I try to go any further, I can't, and I can move the digit over, and I can lower it further still, and then it stops at 8 kilohertz. So it's full range. Again, there may be some jitter. Of course, you won't be able to see the jitter, but there may be some jitter on some of the edges if you're at a funky divider, but that's no more than 200 picoseconds at a time. When you're at 10 megahertz, it's a 100 nanosecond clock. So the jitter is a thousandth of the edge rate. So it really is inconsequential. And so I sort of like this. I was sort of debating what method I would use for setting things, and this works out just fine. And I like the the tune as you go, or set it to some value and then boom, enter it in. So it works out really well. The next step, actually, there were a couple of mysteries that I was working on. One of them was at certain frequencies you get an effect where you lose the number of satellites that you see. And so 14 megahertz was a bad one, and I was trying to figure out what's the cause. It's solid now, but I had this is the GPS unit, and then this is the antenna, and I was wondering, well, is there noise from here leaking in through the power, messing up the GPS? So if this GPS internally is going 10 megahertz, something that's going 10 megahertz, and I'm sending a signal that's a little bit more than 10 megahertz, there's some beating and some stuff that might interfere. And I tried and tried. I moved it down here. I powered it with a different power supply, and I still had that error. And so what I imagined happened, this connection to the GPS antenna, it's pretty flimsy, and I've been using this for weeks, and every time I move it, it moves around, it bends, and there's a chance that on the GPS, I eventually replaced the GPS and the antenna connection, but there's a chance that this antenna connection was no good, so I was actually using the internal antenna, which is right close to this, not as sensitive, and it was getting messed up by just the general noise environment that's here. I mean, if my radio, 5 feet away can pick up all the frequencies here, this guy right next to it certainly can. And so I replaced the GPS unit, which had a different connection, and it's been solid. And I use the same small antenna that's a couple inches away, or as I have it now, I have an antenna that's over by the window, and everything's fine. So it's not noise leaking in. And so in the real system, this is going to be in a metal box with the antenna feed through, and so it's going to be, the antenna is going to be well shielded from all the nonsense that's going on in here. So that's that's good. I still need to do the auto manual thing, although actually I'm pretty close right now. I haven't really tuned it. It just needs to go down a little bit. The one tricky part is getting rid of that phenomena. So when it does the +1, -1, +1 because I'm near 0F, which is the bad edge case. I need to filter that out and then have it so that it figures out what adjustment it would make. And that's going to be the project on the next couple of days. And so initially I'm going to have it be where it's just going to show you what it would do if it was in automatic. It's sort of like, in this situation, if I have this state, what's its tuning suggestion. And so I can play around with it and monitor it and see if it's doing, and behaving the way I would want it to. And then I'm thinking about, the actual system, how what components am I going to use? And, I think that for these buttons, I'll just use this style, push button. I was thinking about, actually, and then for this, the set and enter, I'll use this toggle switch, which, here it's in a neutral position, or I can set it permanently to here. So this would be, this switch, or I can have it in a neutral position, and when I want to do the set, it's a momentary up. And so that's a pretty slick way of doing it. So, it's always here. I can set it, or I can always have it be setting when the switch is down. For the frequency entering, I thought about having, I think I talked about, this knob where you would, you can rotate it, and then you would click it to maybe change, what digit, click it again, go up and down, and so forth. It's kind of clunky software. I was thinking about maybe having one of these things, which is a D-pad, so you can digit each way and then set the value up and down. Trick with this is this has to be mounted behind the sheet metal, and there's going to be 4 screws that look kind of ugly, and then this little cap pokes through. And this seems, maybe it seems a little fiddly. So I might just use these push buttons. And then for the setting these digits, for the DAC control word, I was thinking about using a momentary thing, which would be always centered, and then that's up, and then it'd be momentary down as well. I'm thinking about that, or like I said, the push buttons. I'm still not sure. And then of course the auto manual switch would just be a normal switch. And then on the back, it's going to be one of these BNCs coming out, and then there'll be a BNC feed through SMA feed through for the GPS antenna, which is this right here. And then I'm also going to have, because there's some software that I might want to change someplace here, I have a jumper that would take the Arduino programming connector, and then I'd pipe that through. That's something I was going to use on a clock, but then I decided just the clock software is basically done, and so I did not have that provision. But for this, I'm going to put it in there. Of course, now that I say that, maybe I'll get the software to a state where I actually don't need to do that. I had one little hiccup when I added these switches. If you look at the Arduino diagram here, there are a bunch of analog, these are all the pins, and you see that digital pin, so there's a bunch of digital pins, and every pin is a digital pin. And there are some analog pins. These are these yellow ones are the analog pins. And I put the output enable of the signal on one of these pins, and it wasn't working, and couldn't figure out why. And as it turns out, even though it says digital there, it's not a digital input. It's actually an analog input. It can be a digital output, and this diagram doesn't document that very well. And so I got around that by just having it read back an analog value, and then if it's more than 4 volts it's high. If it's less than 1 volt, it's low. And they got me thinking. I'm pretty much filling up all the pins there, and I was thinking, for the 1 up, 1 down, 10 up, 10 down, 100 up, 100 down, just kind of maybe have actually be 1 pin analog. And so and then it's held with resistors at 2.5 volts, and if you press down it goes to ground, if you press up it goes to 5 volts, and then you can get away with less pins. And so I'm gonna maybe use that if I feature creep this some more and add some more signals. So that's been something I've been again thinking about. So it's looking pretty good. I want to build the analog, or sorry, the auto tuning section, and then I'll do some more tests with the radio and with frequency measurements. I did an experiment a couple days ago where I measured a 15 megahertz WWV signal, and I got within 0.06 hertz, which is greater than my 0.01 hertz goal, but that was due to the Doppler shift that we were talking about before. And so I want to do some studies, measure the frequency over a day and see how the Doppler shift changes on that frequency reference. I also need to figure out the sources of those glitches in the clock that I showed before. That involves, again, more work with the radio, but I've really been focused on the software. I also need to figure out, do I build the actual hardware using a solder version of this PCB, which is good, or do I use something like this, which is what I used for the relay clock, or do I actually build a real fab? The advantages of these is it's basically that, and so I can just take this and solder it up more or less and lay it out more or less like that. What I don't like about that is it's not really space efficient. This is space efficient, so I could probably squeeze all this into a small section, and I'll still have these buttons in play, so I can test it as its own PCB. And then if I actually build a real PCB, that's going to be the best of all, because I'll have power and ground planes. The layout will be optimized. I won't have I have a lot of 10 megahertz and whatever 14 megahertz signals flying over, and that just is asking for crosstalk interference, introducing noise, introducing jitter. So the fabbed PCB will actually be the best thing. And I say it now, I don't want to go through all that effort to learn the tool, make all the parts, blah blah blah, but actually that's going to produce the best results and the smallest layout. And so I think that eventually I'm gonna do that, because there may be other projects where I really would actually want to have a PCB. And in hindsight, the relay clock, it took me 4 days to solder each of the 3 main PCBs. So there's 2 weeks of solid work. If I just drew some schematics, once you make the parts for the layout, it's really easy. And so I might want to just have that as a practice, for next time when I do something more complicated. So I'll probably, I don't know if I'm going to work on this for the next couple of days. Maybe I need a little bit of break, but oh, and by the way, this wasn't at 14 because I was in enter mode, so I just set it to speed it up. So maybe on the weekend I'll start working on the automatic setting and see how well it works at auto tuning. But I'm really happy with the results. I'm glad I did the 8 kilohertz to 90 megahertz setting range. And I'm actually having fun writing the software. Again, my computer science teacher would give me a B- on my effort there, but practice. So thanks for watching, and I'll have an update later.